So Git is one very popularly used version control system, right? So it's a distributed version control system used to track changes in source code during software development, right? When I say distributed, it means multiple people from multiple locations at a time they can work, like distributed systems. One system is someplace, other is somewhere, other is somewhere, all can talk to each other using the internet. In the same way, it's a distributed version control system, right? It helps developers collaborate, manage different versions of code and roll back to previous states if needed, right? So what are the important features of Git? It is open source and freely available, right? And then public and private repository hosting. Okay, you can do, you can put your code publicly or you can make it private also. Okay, and you can work, let's say some 10 developers are building some system, everyone has different locations, they can create a private repository and they can work without knowing the public, right? Can work as a standalone program, right? It can work as a standalone program and it follows distributed architecture. This is very important. Git is a distributed version control system, right? Why I say distributed? See, from one I can, another one I will show you. See, this is the main code. Let's say this is the main code, right? I am creating a branch. I am creating a branch. Like we write, no, this is main code. Then there is a branch B1, and again in branch B1 I can create sub branch C1, C2. Okay. Then there is another branch B2, and there is somebody is working as C3, like this. So parallelly multiple developers are working on the code, right? It is fast and efficient, does not depend on centralized server. Okay, so these are few important features of Git. So the first primary component in Git is a Git repository. Okay, there are so many components which forms this Git or makes the Git very powerful, and the first one is repository, right? So repository is a storage space where your project files and their history are kept. It's a space where you can put your project files, your code can be kept there, right? There are two types of repositories in Git. Local repository, a copy of the project on your local machine. In my laptop I can have that code. Remote repository, right? A version of the project hosted on a server, often on platforms like GitHub, GitLab and Bitbucket, right? So we are going to see all these three remote repository. Basically they are cloud platforms, cloud, okay, cloud platforms, right? So you can host, see, it is obvious that developers will not be working in the repositories like this, remote repositories. What they do, when from the remote repository, from the cloud, they will download that code into their local machine, Here they will make changes, test, play with that code. Why? They try all the possibilities. They are building some new, adding some new feature. They will do some lot of trial and error, right? As a developer, at a single go we don't write final code. We write multiple, we make multiple changes till we reach the final code. So all that game he can play in the local. Only then at the end he can upload back to the remote repository, that is cloud repository, right? So local repository where a copy of the project can be in your local machine, whereas remote repository you can store that in a cloud server. Generally platforms like GitHub, GitLab and Bitbucket. So all these three are linked with the Git repository, right? So if you are using Git, okay, if you are using Git software, then that Git, local is your Git and the cloud is your GitHub or GitLab or Bitbucket. Okay, so we can store them in these three, any of these three, right? See here, I have a local repository. Okay, I am having my code. This is my local, this is my server. I am having my local repository, and there is one remote repository. Okay, this is the actual cloud. This is the cloud, right? So from there you can push and pull. You can put the code and you can get the code. Always you can keep doing this. Like this, multiple people can have the code in their local machines and they can work together. Right? So basically, repository is nothing but a storage space where you can store your files. Then the next one is Git commit. The next core component of Git is commit, right? Commit is a snapshot of your project at a specific point of time, right? Whatever changes you have made, let's say you wrote some 100 lines of code today in your local, right? Before signing off, you have to do the commit. Okay, or not about before signing off. Let's say you wrote 100 lines of code, you tested it properly, it is working fine. Then you want to update this 100 lines in the actual code actual repository, the main repository. You want to load these 100 lines, then you have to commit. Okay, after making changes, if you commit, these changes will be updated in the main code base, right? So if you see, if I just click git status, right, it shows changes to be committed. There is a new file.txt which is yet to be committed. Then you can give this command git commit -m first commit, it will make the changes, right? So we will understand this much better, but basically commit, okay, it is equal to that commit what you do in the database, right? So each commit has a unique identifier and includes a message describing the changes made. You can always give the changes what you are making, message you can write there, right? Commit allows you to track and review the history of your project. So version V1 somebody committed, version V2 was committed for some reason, then V3 was committed, then V4 was committed. So all that you can observe it in the Git. Okay. The second component is commit. Then Git branches, right? So what is this branch? Branches allow developers to work on separate tasks without affecting the main code base. So what we do, when you have a main code base with you, you take that code, main code, you create a branch of it, and then in that branch you will do the changes. Once your changes are done, you can commit it back to the main code, right? So common type of branch are main branch and feature branch, right? So main branch or master branch means the stable version of the project, usually production ready. Main branch. Feature branch used for developing new features or bug fixes, right? So see this green color one is the main branch. Okay, I want to make some change in the code, so I will take one feature branch, I will make changes, another feature branch I will make changes, then I will add it to the main line. I will add that to the main line. Okay, so this main line is here. Now when somebody else is working on feature 2, they will take this, then they will add the feature and they update it back. So everything is updated in the main branch, and you can see all the changes being updated in the main line, right? So Git branches, you will understand this much better when you see the practical demo of these tasks, right? Merging. Okay, what is this merging? So you made the change, you have to merge it back to the master or main branch, right? The main line you have to merge it back. So merging is the process of integrating changes from one branch to the another. Okay, see this diagram here. So C0 version 1, C2, C1 is there, right? Then the final code is C2. The final code is C2, right? Now you have made a hot fix, you have made a change. You have made a change C3, right? You want to merge this. When you want to merge this, right? See what we are doing here, that merge, that C3 which you have merged is updated here as C4, and then the C2 remains same, right? It allows you to combine the work done in different branches and resolve any conflicts that arise. Okay, so again I will explain. C3 is a change you are making, C2 is the final code, but you have taken C1 code and made the change. Now you have to update it back in the main line to the master. So that change is updated here in the main line, and then the master is updated, right? So merging is basically whatever changes you are making will be added back to the main line. That is as simple as that. Okay, your changes will be updated back to the main line or the master line. The next one is cloning, right? Clone, the word cloning you understand, you can create a local copy, right? Cloning a repository means creating a local copy of the remote repository. So whatever is there in the GitHub or GitLab or Bitbucket, the updated one, you can take that and clone in your local machine. Basically, it's downloading in the local machine. This copy includes all the files, branches and commit history. Okay, so once you clone that, you will have the local copy of that code in your machine, right? So these are a few important things. Then, and the final one is pull and push. Okay, now for this you have to understand example of Git and GitHub. What is Git and what is GitHub? See, Git is a version control software. Okay, using Git, I can work in my local machine. Okay, all the developers can work in the local machine, right? And once they make the changes, that this can be updated remotely in a cloud platform called as GitHub. So basically, Git is focusing on local, GitHub is talking about the remote, storing the code online. It's like your Google Doc, document locally in your machine, and Google Doc is a document in the internet, right? So that's what, see, multiple people want to work on a document. That is the best example what we know. If I share a Google Doc to all of you, at a time everybody can work on that, right? So now I want to upload one Google Doc, right? So in your local machine, you add it, you have it. Then you can add and then commit, right? Add means you are bringing it to staging area, then you do the commit, then you are doing the push. You are uploading that document back to the GitHub. So anybody else wants to work on that, they can pull it in their local machine, work, again send it back to the GitHub, right? So Git is your local repository, whereas GitHub is your cloud or online repository, right? So what is pull and push? Push means updating the code back to the GitHub, the cloud platform. Pull is getting the latest code from the GitHub to my local machine, right? Pull and push. Okay, so these are few important commands what we have. And now the three important states, right? Very important, three important states in Git, right? So there are three important states. The first one is working directory. Okay, working directory, staging area, and the final repository. What is working directory? This is your project folder with all files you are currently working on. Okay, this is in your local machine. Right? So basically, you are getting the code from the GitHub. Let's say we are using GitHub as our repository, remote repository. So in GitHub, I have kept one code. I have kept one web application code there. You are given a task of making some changes. Then you will create a branch of it, clone that in your local machine. That in your local machine, when you download that code, that is called your working directory. This is where you are making the changes, right? Any changes you are making here are not tracked by Git. Git does not know because you are doing it local machine. Next, you made some changes in the web application. Then the second phase is staging area. What is this staging area? Right? This is an intermediate area. Where you list the specific changes you want to include in your next commit. You will tell what all changes you have made and that you want to commit. You can use git add command to move changes from your working directory to the staging. It's as simple as that. Sorry. So when I have the code in my working directory, from this I want to move it back to the remote repository. Before moving to this remote, there is something in between called as staging area, right? In this staging area, you will bring your code and put it here, and you will say you are ready to commit it, right? Then the final one, repository, that is Git directory. This is where Git permanently stores the changes of your project. So in the final repository, whatever changes you made in the local are updated back to the directory, right? you can use the git commit command to save the changes, to save the staged changes in the repository. Whatever changes you have mentioned here, that will be updated back in the repository, right. So, this is the 3-step process: modify, then add it to the staging area, and then commit it. Okay. Entire code you are downloading in your local machine, you are making some changes. Those changes, what are those changes, you will list down and put it in the staging area. After listing these changes, then you will give the commit button. Once you give the commit, that is added in the Git repository, final repository, right. So, this is about the Git. Okay. I hope you understood what is Git. It is a version control software or a system. It helps us in making the changes. So, there is something called as repository, then commit, then branches, merging, cloning, right, pull and push, and the 3 important stages: working, staging, and repository. Working directory is my local, staging is means intermediate area where you are mentioning what all changes you have made in the local directory in that code. Then finally, you will commit it to the repository, which will be added back to the repository. Okay. So, Git is your local, right. GitHub is the cloud or the remote. Okay. So, we will be putting our code in the GitHub. Whenever I want to make a change as a developer D1, I will get the code, I will download it, I will make the changes and will commit back. D2 can take, make the changes and commit back. D3 can take, make the changes and commit back. Simultaneously multiple developers can work on a single code or a single application without affecting the others, right. So, this is the Git, that is why it is very popular version control software. Okay.